This is a GamaKay LK67, a 65% mechanical keyboard with a rotary encoder, hot swappable sockets, and wireless connectivity through Bluetooth and a 2.4 GHz wireless receiver. For this build, I will use Gateron Pro yellow switches and Matcha PBT keycaps with an XDA profile. Here's a preview of the LK67 before the improvements. Now I will make modifications to the keyboard, starting with pulling off the keycaps and removing the switches. One major step in making the keyboard sound better is to eliminate plastic on plastic abrasion. This is done through lubrication. The first step is to lubricate the switches. To do so, I will need a switch opener to open the switches. This is done by aligning the 4 tabs on opposing sides of the switches with the 4 legs on the switch opener, then squeezing to separate the top and bottom housings. With the switch opened, we have the top housing, the stem, the spring, and the bottom housing with its metal leaf. I will use GPL 205 grade 0 lubricant to lube the switches. Using a brush to get a light coating of lube on the bristles, I will wipe the sliders of the bottom housing, where the stem moves up and down, and the bottom of the bottom housing. Then I will bag lube the spring by placing it in a resealable bag, adding a couple drops of super lube oil, and shaking it to evenly coat the spring in oil. This is usually done with a full bag of springs and not just one. To lube the stem, I will use a stem holder for better maneuverability. This stem holder will hold the stem from the cross mount. With the stem held in place, I will coat all 4 sides with a thin layer of lubricant. Now, I will assemble the switch by placing the spring onto the bottom housing, balancing the stem on the spring, making sure that the legs of the stem are in contact with the leaf spring, and snapping the top housing in place, ensuring that the RGB slot is aligned with the bottom housing. Next, I can lube and tune the stabilizers. These mechanisms are used on the longer keys to make sure that they don't wobble or seesaw when pressed. To get to the stabilizers, I will use a flathead screwdriver to squeeze the flat posts of the clip-in stabs on either side and pull the stabilizers out. The spacebar's silicone dampeners need to be removed before taking out its stab. With the stabs removed from the keyboard, I can disassemble them by rotating the bar 90 degrees and pulling it out of the stabilizer housing. Before I lube the stabs, I will first wipe the factory applied grease off of the stabilizer wire. Using the same GPL 205 grade 0 lubricant from before, I will lightly lube the inside walls of the stab housing. Then, I can reassemble the stabilizer by inserting the stab stem into the stab housing, with the side with 2 holes oriented so that they are visible through the gap of the stab housing. This is repeated for the right side of the stabilizer. Next, I will generously coat the wire with lubricant, making sure that the lube covers just past the right angles. With one side lubed, I will insert the bar into the stab housing. The wire must be inserted through the stem hole that is furthest from the cross mount. Then I can rotate the bar and clip it into the stab housing. This is repeated for the right side of the stabilizer. Now I can push the stabilizers back into the keyboard and do the same for the silicone dampeners. After pushing the switches back into their hot swap sockets, I realized that some of them did not actuate when pressed down. This was a result of the pins being bent, which caused the hot swap sockets to loosen when the switch was pushed into the socket. Therefore, I had to disassemble the keyboard to resolder the hot swap sockets, which began a multitude of repairs. During my struggles, I was unable to record the entire debacle. Instead, I resorted to a summarized reenactment of the events that followed. To disassemble the keyboard, I first pulled off the rotary encoder knob. I then pushed on the tabs, keeping the top cover in place, and removed the cover. After taking out the spacebar silicone dampeners, I removed the screws keeping the plate in place. and carefully disconnected the battery from the PCB. This is a slide toggle cover, which shortly became the bane of my existence, but I'll get back to that later. Next, I removed the screws holding the plate and PCB together. And here are the hot swap sockets that sit underneath the PCB. To fix the loose sockets, I had to resolder these two ends to secure the connection. After fixing the hot swap sockets, I tried to reassemble the keyboard, but the slide switch toggle cover kept falling out of place. As a result, I accidentally snapped the slide switch toggle. With the toggle snapped, I had to replace the entire slide switch, which was used to change between the wired and two wireless modes. However, the 8 pins on the switch were so small that I stripped 4 contact pads when trying to remove it. Therefore, I had to carefully scratch the surface of the PCB with tweezers to try and reveal part of the PCB line and reattach a contact pad. I used alcohol prep pads to clean the surface, and copper tape to replace the ripped contact pads. While soldering the copper tape to the revealed PCB line, I made sure to use rosin flux to prevent metal oxidation for a stronger bond. This was applied onto the surface using a cotton swab. After meticulously attaching the copper tape, I then soldered on a new slide switch. To test the switch, I connected the battery and changed to one of the wireless modes. The slide switch is a bit crooked, but it works. Now I can finally reassemble the keyboard, starting with screwing the plate back on, then reconnecting the battery, and putting the slide switch toggle cover back on. As you can see, this cover still kept falling off, which was what caused the debacle in the first place. This time I taped the cover to the outside of the keyboard to keep it from falling out. After that, I was able to secure the PCB onto the bottom of the keyboard. To make sure everything was working, I used the tweezers to check the resoldered hot swap sockets as the keyboard was in wireless mode. Next, I reattached the keyboard cover and pushed the rotary encoder knob back on, as well as the spacebar silicone dampeners. To make sure that all the hot swap sockets are working, I repeated the tweezers test for the entire keyboard. Now I can finally put on the switches and keycaps. And here it is, the finished product, the LK67. Thank you.